Okay, so thanks a lot for coming to another amazing edition of Voxed Days Zurich. This year I'm organizing the first Voxed Days in Milano, as you heard during the welcome talk. So it will be next month, the 13th of April in Milano. So if you didn't get enough today, you can move 3-hour trains south of here, and you will have another amazing Voxed Days. I'm here to speak about, as usual, about functional programming. You know that I love functional programming if you know me. But I would like to give you a quite different point of view this time. I mean, this talk started from this joke, and you can find a lot of similar joke on the internet. I mean, you have a different patterns and strategy and best practices in the object-oriented programming that we created this set of patterns and best practices in the last like 25 or 30 years, and the joke is that everything resembles everything. You can do exactly the same thing just with a function if you do functional programming. And well, this is of course not entirely true, and this is yeah, it is a joke, probably a bad joke, and in reality, I involuntarily probably passed the same idea in my former talks. For instance, I don't know if you were here, but a couple of years ago I did a live programming session. I had a list of object-oriented designed pattern implemented following the Gang of Four book, and then I tried to rework them in a more, you know, compact way, less verbose way, doing functional programming in Java 8. So I have this repository on my GitHub, and then there are, if you are curious to give a look, there are these examples in both object-oriented and functional style. And then I linked a couple of other contributions because one guy did the same thing in Kotlin and another one in Swift. So if you are interested in these various implementation, you can start from there. But by doing that talk in particular, I think I passed the wrong message. I didn't want this. I didn't want to say that we should throw away everything is object-oriented and just starting doing functional programming. This is not what I mean. This is just, and moreover, it's not true that one thing excludes the other. You can take the best of part of the two things, okay? And in reality, by saying object-oriented versus functional programming, we are just introducing a false dichotomy, okay? And a false dichotomy is typically a way of oversimplifying a complex problem. And we have a lot of similar example in our day-by-day lives. We are saying that we have a lot of false dichotomy in our newspaper and the television. They are telling us that either you make the customer, the normal people happy, or you make make the market happy. You cannot do both. This is not true. They are telling us that either you care about the local or you want the immigrants. You cannot make everybody happy. This is not true. There are synergies that can rise between the two things. They are telling us that either you do the interest of your own country or you care about having a community, a community of country. I know it is weird to do this discussion in Switzerland, but it touches me a lot being an Italian, and probably you know the situation in Italy. So sorry about this, but I really don't like what is happening in Italy. And again, what is happening in Italy politically is because of this false dichotomy thing. They are saying either this or that. And it is not true. It's the synergy of the two where you really win, okay? And then the same is for instance, for this new green movement created by that Swedish girl, Greta. Probably you heard about this. And she says something very simple. She's not saying we have to stop all the industries, we have to be green, nobody should work anymore because we have to be green. She's saying there is a different way of doing industry, of creating product, of creating good program that is compatible with the green technology. Okay, so there are lots of these false dichotomies, and the software development, it's the kingdom of false dichotomies. We have a lot, of course. Okay, so they are telling you that you have to choose between a SQL or a NoSQL database. You cannot have both. You cannot mix both. This is not true. Of course, you can have both and use the best of the two things in your software. And then they are telling us, okay, we don't want this monolithic sheet anymore. Now we are creating microservices mini sheet. But when there is not a true separation between these two things, when a monolith is fractionated enough to be a microservices, why I cannot mix the good part of the two worlds? Okay, and this is also there is also a false dichotomy that I care a lot, because I work for Red Hat, as you can guess. And in particular, I work on rules, which is the rule engine of Red Hat, and they are keeping telling us that the rule engine are the old style artificial intelligence. Now everything is machine learning. You don't have rule business anymore. The neural network can guess the business rule, and then you go to Amazon, you buy a brand new phone, as I did a few weeks ago, and then Amazon start bombarding you, say, okay, you bought that phone, maybe you want another phone. That is totally no sense, and you can explain this. Of course, a phone is statistically related to another phone. So, and the artificial intelligence of Amazon thinks that, okay, these two things are related, so if you bought A, I'm suggesting you B. But of course, I don't want a second phone, I just bought as another first one. And if you mix that statistical inference from machine learning with a simple rule, business says, look, this guy just bought a phone, don't suggest another phone to him, okay? It's a simple business rule. Probably a neural network cannot get this, but can guess this. But a simple human can. And if you encode it in your software, probably with a rule engine, you will take the best of the world, okay? So and today, of course, I'm speaking about this further false dichotomy that again probably I contributed to create, but I didn't want to. Okay, and this false dichotomy comes from a few misunderstandings also. The first misunderstanding is one that I underlined in that live coding talk that I mentioned it before. When somebody speaks about object-oriented programming, we are used to think about this stuff, okay? But this is just a distortion of the thing. I mean, it's pushed to the extreme consequence. It doesn't have to be like this. This is object-oriented. This is 25 years old object-oriented programming, and if you push this thing to the extreme consequence, you then have design like this, okay? And this is not what really you want. You don't want these. Yeah, there are these fancy names here, and if you read the class name of some framework, sorry, but Spring comes me to mind. You have this abstract factory, creator, instantiator, whatever, and that is the object-oriented push it to its extreme consequences. But again, it doesn't to be like this, and in reality, it wasn't like this. So Alan Kay is the father of object-oriented programming, meaning he's the guy who invented the term object-oriented. And he said that when I created the object-oriented term, for sure I didn't have C++ in mind. Okay, and Java is just a better educated C++ with garbage collection in a memory managed environment. This is all. Okay, and this is not what we had in mind. This is a misunderstanding, a distortion. This is probably one of the biggest misunderstandings in engineering. In general, okay, in the history of engineering, whatever kind of engineering, civil engineering, or this is a big misunderstanding. Okay, what Alan Kay had in mind was object-oriented programming. What the Gang of Four and what we do day by day is more class-oriented programming. Okay. Alan Kay had a totally different idea. You have an object, which is the owner of its state, and that's all. And nobody else can change the state of the object. And then you have a set of objects, of course, and this set of objects communicated through message passing. Okay, so you didn't have any race condition because the only owner of the state of the object was the object itself. It couldn't be changed from outside. And then you have this communication between objects through message passing. Okay, and if you think about it, this is the actor model. This is the actor model introduced by Erlang and popularized by Scala and Akka. Nothing more, okay? So even there, it seems to be a great new idea at time, but it wasn't. It was small talk on a multi-threading system. So there are a few myths about object-oriented. Again, they comes on how we are used to think about object-oriented. And there are also some myths about functional programming that are clearly not true. One of the myths is that functional programming is a totally new thing, is the new cool technologies. And as Venkat said during his keynote, everybody likes new stuff and wants to try new stuff, but it is not true. Functional programming came from the theory behind functional programming came from the 1936, the lambda calculus introduced by Alonso Charge, and also Haskell, which is the most functional programming functional language around, is 5 years older than Java. So it's not something new. It's something that we are started using more and more recently because of a reason. Because recently, only, let's say in the last 10 or 15 years, the multicore processor has become a commodity. Everyone have it, and it's often easier to do parallel programming in functional programming style than in imperative object-oriented style. This is why functional programming is getting traction in the recent year, but it's something very old. And again, this is another very misconception. I'm doing functional programming, but what this means? Does it mean that you do pure function like Haskell, and also Haskell can do tricky stuff so that it's not pure anymore, or you just are using a few Java 8 lambdas here and there, and then you are a functional developer. And then there is a lot of shades of gray in the middle. So there is not something well defined that say, okay, from this point on, I'm doing functional programming. And as I said before, the same applies also for object-oriented programming. There are a few misconceptions about this, and they are not well-defined terms. Okay, this is probably the main point of my talk. Functional programming is not the opposite of object-oriented programming. There isn't any dichotomy again. They can be mixed in an effective way. Functional programming is hard. I heard a lot of this in the past, especially when Java 8 has been introduced like 5 years ago now. Yeah, it was 5 years ago yesterday. And people starting say, we don't really get this lambda thing, we don't really get this function thing. I heard of this a lot. And I believe it's just a matter of familiarity. And I went to the same process. I mean, I started being a software developer like more than 20 years ago. And for the first 15 years of my career, I've been doing object-oriented programming. Not only object-oriented programming, but object-oriented programming in the style of the Gang of Four book. Okay, so that was something also new for me. I was just not familiar with it. We were confusing complexity with familiarity. It wasn't harder. It was just less familiar, and we are starting being more familiar with this paradigm, with these patterns in recent times. This is another myth that I heard a lot. Functional programming is less efficient. This is not true. Or this is true, but for a specific reason. I mean, this is true, for instance, often in Java. Why so? Because in functional programming, you try to enforce immutability. Enforcing immutability means that instead of changing the state of an object, of a data in place, you have immutable data, meaning that you throw away the old data and create a new data. This is why you do immutability, and this means that you create a lot more object. This means that you put a lot more pressure on the garbage collector, and then this is why functional programming is perceived like a bit slower. But it doesn't to be like this. It's just because again, Java is born like 25 years ago. The compiler, the bytecode, the Java virtual machine has been optimized for those kind of pattern, for the object-oriented pattern. And nothing prevents the compiler to be smarter or to avoid allocate so many objects when you do functional programming. It's just not happening now, but it's just an incidental thing. It doesn't mean that functional programming is structurally less efficient than object-oriented and imperative one. Of course, this is not true. This is another misconception. Lots of I don't know, investment bank in London or here in Zurich, I guess they do functional programming in Scala or in Haskell because it's nice for math computation, but it doesn't be just like this. I mean, you can also have, for instance, a graphic user interface in a very functional programming style. Think about the functional reactive programming, which is based on React on an event by using a function implementing the action behind that event. This is related to the other point. Functional programming is not the opposite of object-oriented programming, and for the same reason, it's not an all-in or all-out game. You can use functional programming with judgment in portion of your software, but you can mix. You don't have 100% pure to say this is functional programming, okay? And this is another very big misconception. Okay, now I'm a functional developer, and now since I'm having I have lot of lambda expression in my code, so a functional programming, and now my code is clean, and I have solved all my problem. And this is of course not true, because you can write crappy code in functional style, in object-oriented style. You can write crappy code in assembler or in Scala. So this is not really true. So I went through a few myths about both object-oriented and functional programming. Now I wanted to restart from the definition, at least for the definition of object-oriented and functional programming, as we are used to think about them, okay? So at the core of the object-oriented programming, there is this entity which we call object, which is something that put together a set of data and defines the operation that you can perform on the data, okay? On the other side, functional programming treats computational programming in a more mathematical way. So the best feature that you have when you do functional programming is mathematical composition, okay? So you create complex program by composing different mathematical function, or should be mathematical function. When I say mathematical, meaning that they should be pure, they shouldn't have any side effect. So, but in reality, what's the difference between the two? Under a syntactic point of view, for you and for me, the difference is this one, right? In one case, you have an object and you call a method on that object. And in another case, you have a function and you pass the object to the function as an argument, okay? But if you think about it, these are exactly the same thing, okay? There is no difference, or there is one big difference, but it's not evident in this syntactic representation. And indeed, probably this is the right representation, okay? You have a data, you have a function operating of the data, and closure, small Lisp, put them on the same level. You have a function and that operates on data and the data that are being operated, okay? So they are on the same level. And this concept is the fundamental building block of the MapReduce algorithm, if you think about it, okay? So what was the original idea behind the MapReduce? Is that you have lots of computation to be done on lots of data, and you have this data on multiple machines, of course, because they are too big to stay in a single machine. So you have this data on many machines, and you compute, you do all the computation in parallel, and then you put everything together. But what was the trick there? The trick was that I have 1 terabyte of data, and I have 1 kilobyte of the body of a function that has to operate on the data, okay? If they were different things, if a function was something structural on that machine and I couldn't move in, I was obliged to move 1 terabyte of data from one machine to the other to do the computation, not at the other machine. But this is not true. Okay. Also, a function is a data. So if I have to choose between moving 1 terabyte of data or 1 kilobyte of the bytecode of a function, what is the intelligent thing to do? I move the 1 kilobyte function on the machine containing the 1 terabyte of data, right? And why you can do this? Because you are treating function and data exactly in the same way. Okay, they are the same thing, and so you can decide how the most convenient way to deal with them. So this is the meaning of this notation of this Lisp notation that puts F and O in the same at the same level. But as I was saying, there is actually a difference that this notation implies. Is that with the object-oriented style notation, you actually have polymorphism, okay? And polymorphism is really the big advantage of object-oriented programming. And why it is important? It is important because, as you will see with the next example, you have a different way of decomposing problem by using polymorphism. But the most important thing is that polymorphism allows you to not create a dependency between the code processing the data and one of the instantiation of the data. So you can have a general interface that exposing some method, and you can define the operations against that method. And then you have a concrete class that can be in another jar. But the jar, the library operating on against the interface, that doesn't have to depend on the library containing the concrete class, okay? And with functional decomposition, you don't have this advantage. Let's see it with a concrete example. So I have a few types, and I have a few operations to be performed, developed, implemented against those types, okay? So I have an integer type, and the addition, negation, and I have different operation, the evaluation of that expression, the transformation of that expression into a string, and a predicate that tells me if that expression has a 0 or not. And you can add, of course, vertically add more kind of data, and horizontally add more kind of operation. And then you have two kind of way you can decompose this problem. One is the object-oriented way, the object-oriented style. So you start working with the row. Each row is an object, and then all those operations in the column are the implementation of that operation for that object. So you basically are the method that you add into the object, okay? And conversely, you can have the functional decomposition. So you define the function as 0, and then that S0 can accept a different kind of object. And well, in functional programming, you usually use pattern matching in this case, or if you don't have pattern matching, you can use a list of if-else blocks. But you, based on the kind of object of the kind of data you are passed, you do different operations. So let's see this with a very simple example. I defined an interface expression, and then I implemented, well, and the interface expression contains the signature of those functions of those methods. And then I have the different implementation, which are my concrete expression implementing one method for all of these operation. This is the classic object-oriented decomposition. If you want to do the same with functional decomposition, you just have the data without any operation inside, and then you have the function where you pass the data to it, and you do something different regarding if you have a certain kind of expression or another, okay? So again, what's the biggest advantage of object-oriented programming in this case? Is that if you have a piece of code working against the expression interface, and the addition, int, and negation class are in a different jar, you don't have to depend on that jar to define operation on the expression. You just program against the expression. You cannot do this in this case, because if you are implementing operation with functional programming style, you have to have a dependency on the library that contains your concrete classes. Okay, but except for this difference, it's hard to say which one of these two way of decomposing problem are better. And as usual, there is not a solution that fits all your problem. Regarding of the problem you have at the end, you can probably do something different. So, for instance, I work a lot with interpreter and parser, and for me, the functional decomposition style, it's easier in that specific case. But probably if you do user interfaces, the object-oriented style is much more easier, because at each object, at each button or text area, you have different kind of behavior associated to that object, and then you want an object-oriented decomposition. So the two kinds of decomposition are good, and as usual, if you just know one of them, you will always use that one, but probably you are in a specific case when the other one will be better. Okay, so this is the object-oriented versus functional decomposition, and while I was preparing the slide, the next natural step for me was, okay, I have talked about decomposition. Now, of course, let's talk about composition. Okay, but I found that they have a very different meaning. I mean, as I said before, the key point of functional programming is composition. What you do is have small simple function, and you compose function to create complex behavior. So functional composition is very at the heart of functional programming. Okay, object-oriented composition is a bit more awkward in my opinion. So, and normally you do this in this way. You do this with inheritance. So you start creating your tree of your taxonomy of object, and then you start with the situation on the left, and soon end up with the situation on the right, of course. So probably, now we started figuring out that probably inheritance is something incidental in object-oriented programming. We associate inheritance, object-oriented programming with inheritance, but also because, again, of the Gang of Four book. But it doesn't be like that, okay? So we are telling us that actually the best way of doing object-oriented composition is by association, okay? So, and I agree this is true, but normally the way we do this is by using dependency injection, and sometimes dependency injection can go wrong for strange reason as well. So they are very different concepts, and you have to deal with them carefully. So I talk about the biggest advantage of object-oriented programming, which is the polymorphism. There are, of course, a lot of advantages in functional programming, and they more or less derive from the same concept. The key point of functional programming is immutability, and as you know, immutability makes trade safety make trade parallel programming easier, then enforces better trade safety, and then if you have immutable value, it's super easy to cache them, because you don't have to worry about when you have to invalidate the cache. The data is immutable, so the cache doesn't need to be invalidated. And then it's easier to reason about immutable object to check that your code is correct and is consistent, okay? And this is something very similar to what Venkat said during his keynote. If you remember, the very first point his presentation about, of Venkat presentation about complexity was the mutability. He called them the moving part. They are the moving part, okay? And one of the difference between traditional object-oriented style and functional programming style is that the way they deal with moving part. The way object-oriented deal with moving part is encapsulating them. Okay, so you encapsulate a set of data inside an object, but then you have other object from the outside trying to change in that data concurrently. So encapsulation is not really a solution for this often. And functional programming takes a different approach. We don't want to encapsulate the moving part. We basically don't want them. We try to minimize them. We find that the moving part are a problem. So instead of finding smart workarounds for the problem, we totally remove the source of the problem. Okay? And then you have when you start thinking in terms of immutability, you have other nice features that derives from immutability, which are for instance, the referential transparency. What this means is related with the caching thing that I was saying before. Referential transparency means that every time you perform an operation on a given data, the result will be always the same. Why? Because that result is only dependent from that specific data, and there isn't any other external data that affect the computation. Okay, and the two things are related, and this is the typical example of to show referential transparency in relation to immutability. Of course, you know that in Java the string is an immutable thing, while the string builder is mutable. And if you try to apply the same programming logic to an immutable object as a string, you will get with the right result. If you do exactly the same with a mutable object, you will get the wrong result. Why? Because you are mutating the object in place. So performing the same operation on the same object resulted in a different result, because the operation is also dependent on the internal state of the object, which is changed in the meanwhile. So referential transparency again is related of the fact of not having side effect. And if you don't have side effect, again, if you don't have mutability and you don't have side effect, you can do caching very easily. Okay, so you can always replace the result, a computation with the result of that computation, because performing that computation doesn't have no side effect, so you don't have to execute the computation more than once to gain the side effects. There isn't any. And then the result never changing, so you can cache it, for instance, with the compute_if_absent send method, which has been added in Java 8. Another very interesting difference between object and functional programming is the way in which we manage errors. So what's wrong with this signature? This is a very typical way of designing your API in object-oriented style. You are trying to parse a string into a number here. If the string doesn't represent a number, you will be signaled of this by getting a number format exception. But this is wrong, because I cannot cache the result. I have the throwing an exception is a side effect. Okay, it's not referential transparent. And it's really wrong here. I mean, it's not an exceptional condition that I cannot convert a string into a number. The biggest part of string that doesn't represent a number, there is nothing exceptional in this. It's just a something that may and will happen, okay? So I believe that the correct signature for that method is that one with the optional int. No exception, but just a result that is saying, okay, this string can be eventually converted in an int. Can be or can be not. So it will not return the result, but will return an optional of that result. Okay, and by doing so, I can cache the result, because of course, if I'm passing with a string that is not convertible in an integer, I just can cache for the string the optional int empty as a result. So again, I really don't like exception. In particular, I don't like checked exception. I'm not saying don't use exception, like I'm not saying don't use dependency injection, don't get me wrong. I'm saying use them carefully. And applying the functional style makes you think about it, okay? So let's come also with a different example. I did this example a few times ago, and I discussed a lot this example with friends. What this is about? I'm doing exactly the same operation in a imperative, in an object-oriented style, and in a functional style. And what I'm doing here, I'm parsing a log file, and while parsing it, I want to filter. I want to get all the log file the log statement that start with error, and I want to take the first 40 of them. Okay. And if you look at the code, okay, the second one is really much more compact, of course, but this was not at time the main point of that slide. The main point of that slide is that is what you are saying with the color, okay? But what is color are saying? The red is saying, in that case, I'm dealing with the traversal of the file, and the same red thing is scattered around the code. So the traversal of the file in imperative programming is not in one single place, it's around your code, okay? And the same thing to filter, well, the filter is only the thief, but to limit the result to the first 40, still you have a counter, and then somewhere else you have to increment that counter, and somewhere else you have to check if you reach that value. So the code is not cohesive as well in the functional, in the imperative style, okay? So these slides has become quite popular, and everybody say, well, look at this wonderful, wonderful code. I just want to do this, okay? And then I had a discussion with my very good friend Simone Bordet, who is the main maintainer of Jetty. And he used to challenge me for a reason. And he said, okay, I have this log file, but instead of having only the first 40 error message, I want that error statement plus the statement before the error in the log file. Why? Because sometimes a message immediately before the error can give me some hint about the error. It's a perfectly valid requirement, right? But with this very perfectly requirement, I try to implement that reasonable requirement inside my beautiful code, and I had this effect, okay? Simone was simply putting a Mentos in my Coke. Why? Because I tried to do this exercise, and yes, I did the exercise with the object-oriented style. Well, I had to make a bit more complex my code. I have to add a new variable to keep track of the previous line. But basically, I had the original code. I changed it a bit. It took me 10 minutes, and I was done. Okay? And unfortunately, this is not the same for the functional version. So I tried to... why? Because the problem is that while you are traversing a stream in a functional style, you have that object under the stream, but you don't have an history. And it's with the Java language, with the Java API, it's very hard to do this. Okay, so this was my first attempt, which is very ugly. Here I'm traversing once the log to create the pair, the combination of. So each pair is one line and the line after, and then I check that if the second line has the error, and then I have the pair. But this is two problems. First of all, I was cheating here. I'm using mutability because to create this pairing, I'm using mutability, and even worse, it's not lazy anymore. So I have to traverse the whole file to create this pair, and then I have to traverse it once again till the first 40 error. So this is quite inefficient. And then I working on it a bit more together with Simone, and we end up with this solution. For some reason, in Java 8 you don't have, or in Java whatever, you don't have a zip function, a function that allows you to zip to streams. So, but we created one in a quite reasonable way. And then what we did is taking the two stream, shifting one position, so prepending one of the true stream with an empty thing, with a null, and then we zipped these two stream to create the pair. Okay, and at that point you once again you are traversing the stream twice. That's true, but you are not traversing till the end. You once again have the lazy effect, so that when you reach the 40 element, you don't traverse the thing anymore, the stream anymore. Okay, so this is a pretty reasonable solution, but it took me a lot of effort to figure this out. First of all, because I didn't have the zip function. Second, because again, it's a matter of familiarity. I was not very used to reason in this term. And the third and probably most important thing is that I was able to achieve Simone requirements in the object-oriented style by changing some bit here and there. And for the functional solution, I had to rewrite totally it from scratch. Okay, so why I'm discussing this example? Because I wanted to show that the truth is in the middle. Okay, the original example is super nice, super cool. Everybody loved it when I showed it in the functional style, but there are some caveats like this. And then I have. I'm running out of time, so I had some small example to see to show the parallel of object-oriented and functional programming. But I actually discussed more or less of the biggest part of them. So in object-oriented, you have a stateful processing, and in the functional style is stateless, and this is a good thing. But usually stateless is a good thing, but again, if you remember that last example, it wasn't that good in that case. So it depends on your case, okay? And here, yeah, well, I wanted to show the difference between stateless and stateful. Sorry, I'm running out of time, so I will rush on this. And there are a few other differences. For instance, you have a typical object-oriented style is using expression, is using statement, while the typical object functional style is using expression. And normally, if you can, you should prefer expression once again before of composition. And this is the key point. I found this blog saying, it was a very short but interesting post saying, okay, so let's use functional programming in the small and object-oriented in the large. So here I'm trying to find a synthesis between the two. I'm trying to find a way to put them together. And one of the suggestions that I found on the internet was this one. Let's do the functional programming, the arithmetical style in the small, and have the orchestration with object, okay? But for me, also the opposite is totally valid. Let's do the small thing, the mutable thing with object, and do the orchestration with immutable function. It's totally valid as well. Probably I prefer this second thing. What I want to say with this is saying that I don't have an answer, because there is not an answer that fits all, okay? So the bottom line, the end of message is you cannot do 100% functional programming, or at least I'm not able to, okay? And probably also 98% is not reasonable. But probably 80 or 85% is good enough, and then you do object-oriented when you really need it, okay? Which is the same thing that Voltaire said like almost 3 centuries ago, okay? Perfect will be the 100% functional style, but usually perfect is the enemy of good enough, and we want good enough. And that's all. Thank you.